Hello students, today we will discuss about electric dipole, in which we will see what are the electric dipoles and what is electric potential due to dipole system and what is electric field due to them and the torque on the dipole when it is placed in electric field and the potential energy due to electric dipole. So today we will discuss all of these one by one. So let us start from electric dipole, the definition of it. Electric dipole. If we recall, then in grade 12 we have studied that equal and opposite charges separated by a small distance is termed as electric dipole. The charges must be equal and the polarity of these charges should be opposite, and the distance between these two should be low, so that these two charges are not free from each other, they are bound charge. So if this condition fulfills, then they are known as electric dipole. The condition is that these two charges are equal and opposite sign with a small separation, and the charges are bound charge. So after the definition, if we wish to define it, then the term that is given for them is dipole moment. So in the case of electrical charges, it is termed as electric dipole moment. This term gives the visualization of the charge and the separation of these two. So it measures the separation of the positive and negative charges in the system, and it is written as electric dipole moment. That is nothing but the multiplication of the charge with the separation. This is known as electric dipole moment. And as it is vector quantity, it has a proper direction, and the direction is from minus q to plus q against to the electric field. In electric field, the direction of the field is away from the positive charge. Here it is just opposite to that. Okay, these are the basic terms related to the system. Now, if we know these basics about the dipole and the dipole moment, then the terms that we have defined in the case of point charge, line charge, or different arrangement of the charges, we have to define here in the case of electric dipole system as well. So the first term that we wish to define is the electric potential due to dipole system. So for that purpose, let us electric potential. This is the main term that we wish to cover today. This is the dipole, negative charge, positive charge, and the separation should be very small. The separation between these two is d. Okay, and to find the electric potential, we wish to point if we wish to find the potential at any point P that is away from the system in any coordinate, for example, consider a spherical coordinate system, then for this purpose, what we can do, mark the middle of this, the distance, the position vector of this is r, and the position vector of this point from the positive charge is r1, and from here it is r2, and if we consider consider this angle as theta. Now the position vector of r1 is in this direction, r2 is in this direction. The position vector of this dipole at this point is in the direction of this. We can write like that. Then the potential, if we consider only one charge, in that case the potential at this point due to this charge can be considered as V plus, due to plus Q can be considered as KQ by R. So K Q by the distance between these two. Now V negative can be considered as KQ by R2. We know this, we have studied it already. Now if we wish to find the potential due to the combination of the charges, then it follows the superposition principle. That will be equal to the 1 by 4 pi epsilon naught. Take sum of these two, that will be this plus this. Take this thing common, so it will be Q by R1 plus and minus from here, so it will be minus Q by R2. We can write like that. Take the Q outside, it will be 4 pi epsilon naught 1 by R1 1 by R2. We can write like this, and after further simplification it will give us 4 pi epsilon naught R2 minus R1 divided by R2 into R1. Okay. Now consider some assumption, that is, if this point is very far from here, with very far means the distance of this distance is very larger than this. So if we consider that D is very low than the position vector, then in that case this angle and this angle can be considered as same if this point is considered very far from here. And if we reconstruct like this to make this length and this length equal, then R2 minus R1, that is here, can be written as Q by 4 pi epsilon naught R2 minus R1 divided by R2 into R1. This R2 minus R1 can be written as R2 minus R1 can be written as this length, and if it is D, it is theta, it is almost 90 degree, then it can be considered as D cos theta. It can be written as, and this is first assumption, and if it is so, then we can say R1 will be equal to R2 will be equal to R approximately. So this term further can be modified and it can be 4 pi epsilon naught. Here we can place d cos theta, and this can be written as r into r, that is r square. And if we further simplify this, then we will find qd cos theta divided by the previous term. Okay, this is V due to dipole moment. Due to this dipole system, the potential is this. So Vp further can be written as, can we write this P? Qd can be written as P cos theta 4 pi epsilon naught r square, we can write like that. And P cos theta can be written as, further it can be written as P dot the unit vector in the direction of radial position vector. It can be P A cos theta. Theta is the angle between radial vector and P. So 4 pi epsilon naught r square. This term further can be written like this. So this is our final term. The potential, electric potential due to this electric dipole at any point P will be P dot AR divided by 4 pi epsilon naught, the position vector square. Okay. Now let us try to find the electric field after the electric potential. Then electric field can be written as, we know electric field. This is based on the previous study. E is nothing, just rate of change of V, del of V. We know this. And the system is in spherical coordinate. So we can write this del over del R in the direction of AR, or we can say V in the direction of AR, okay, negative is for all, plus, if I am right, please rectify this if there is some, del V over del theta, here it will be in the direction of A theta, and it will be R sin theta del V over del theta in the direction of A phi. Hope it is right. Okay. So in the spherical coordinate system, we can write the del V like that. And we know V is given here. Then we can say del V over del R, it can be the del V over del R can be, just differentiate this with respect to R, so it can be P cos theta divided by 4 pi epsilon naught my R to the power minus 2, it should be minus 1 by R. So it should be minus r. No, I have integrated this. So it should be minus 2 by r cube. Yes, I think r to the power minus 2 will be here cube. Okay, I'm sorry, it is okay now. So dv over dr. Now similarly, if we differentiate with respect to theta, then it can be, because there are two variables only, r and theta in p, then we can find p sine theta divided by 4 pi epsilon naught r square. Okay, here the differentiation of cos theta is minus. Now it is okay. Now the third term, that is phi. I'm sorry, here it is phi. The third term is del v over del phi, and there is no phi term, so the derivative of v with respect to phi will be equal to 0. So in the direction of a phi, e component a phi in the direction of a phi will be 0. So this term will be 0. The only term will be these two. So we can write minus this and minus this. So it should be plus p cos theta divided by 4 pi epsilon naught r cube, and this 1 by r, this is minus p, so it should be minus p sine theta 4 pi epsilon naught r cube. This is in the direction of ar, and this is in the direction of a theta. This is the electric field. So we can say the electric field is 2p cos theta by 4 pi epsilon naught r cube in the direction of ar minus p sine theta divided by 4 pi epsilon naught r cube. Okay, if this is minus and we'll put here, then this minus multiplied with this, it should be plus. So this is the final term. The electric field will be like this. Electric potential is this and electric field is this. Now after electric field, let us discuss the torque. Okay. Now in the case of torque, suppose this is electric field, okay, and any dipole here is positive charge, here is negative charge according to its definition, and this is center, you can say this is R. Okay. Now if this dipole is placed in the electric field, then what will be the torque existing on this dipole? So for that purpose, as we know, direct finding the torque, before that we should know from the physics, torque is R cross F. So it is important to find F first, then we can come to torque. And we know if any charge is placed in electric field, then the force at the charge can be, force as positive charge can be equal to the charge into electric field. From the formula we know, we have derived it already. And if this is QE, and similarly from at the negative charge, force can be minus QE. Okay, so it means the force direction is in the direction of E. The force direction is out of the opposite direction of E. So the direction of force here will be in this direction. The force at this will be in this direction. Okay. So if we will consider this as a system, then net force will be equal to the force positive plus force negative, because there are only two forces acting at this system due to this electric field, and this is QE and minus QE. So including these two, it will give us 0. So the force on this dipole will be equal to the 0. And to find the torque, we will consider the center of this dipole, and this length is considered as, if total length is d, then it is considered as d by 2, and this will be equal to d by 2. Okay, so the torque on this will be, torque 1 can be written as R cross F, that is d by 2 cross F, or what we can say, d by 2 F sine theta, if this is the direction of R, this is the direction of F in the direction of E, the angle made by this is the theta. This is E, this is R. So the angle of R d by 2, and in between these and this is theta. So this can be written as the torque acting on this positive charge. Now the torque acting on the negative charge will be, it can be considered here, this is d by 2, R cross F again, it will be d by 2, and it is in the direction of AR is in the direction of R is in the direction of this, and this is the direction of F. So both are in opposite direction. This is AR. If AR is considered as positive here, then it is considered as negative here. F is also considered as negative here, because we have considered F in the direction of this as positive. So it can be considered as minus R minus F, and due to this it will be sine theta. So it will give us d by 2 F sine theta. In this way, if we wish to find the torque on the system, then it can be the total torque existing on the system will be this, and that can be d by 2 F sine theta plus d by 2 F sine theta, and it further can be written as d Q E sine theta, because F can be written d by 2 and d by 2, it can be written as 2 times this, and 2 this will be d. F can be written as QE and sine theta, and this can be written as P. If you remember, in the few minutes before we discussed this, sine theta, and if PE sine theta, further it can be written as the cross product of P and E. We can write like this. Okay. So, and the direction of dipole moment is from negative Q to positive Q. So the direction of torque will be, this is the direction of P and this is the direction of E. So the direction of torque will be the cross product of P and E, that will be inside. Now let us discuss the potential energy. And change in potential energy can be written as, from here, PE sine theta can be written as cos theta, and cos theta with minus sine from theta 1 to theta 2. We can write like that. Okay, because the integration of sine will be minus cos, and minus came outside. Now we put this. Now it will be PE cos theta 2 minus cos theta 1. Okay, so what we can say, change in potential energy is the potential, we can say, minus PE cos theta 2 minus PE cos theta 1, that is minus U at final minus U as initial. So in this way we can say this is the change. So if we wish to write the potential energy, then we can say it will be PE cos theta with minus sign, because this is the final and this is the initial. So we can say PE cos theta, this is the potential energy, and further you can write minus P dot E, because it is also vector, this is also vector, so the dot product of these two will give us this. So U can be written as, that is potential energy can be written as P dot E with minus sign.